Good morning, students. Today we are going to study chapter number 5, Physical and Chemical Changes. A number of changes takes place around us, such as burning of wood, curdling of milk, water changing into vapor, tearing of paper, and rusting of iron. These changes can be categorized into physical and chemical changes. Physical changes. A physical change is a change in which the physical state of a substance is changed. Physical changes do not produce any new substance. Such changes are related to changes in the physical properties of a substance, such as density, mass, volume, and viscosity. Now let's know about the characteristics of physical changes. They bring about changes in the physical properties of the reactants. No new substance is formed in physical changes. Physical changes can be either reversible or irreversible. Heat may either be absorbed or evolved in a physical change. Physical changes are mostly temporary in nature. Chemical changes. A chemical change is a change in which a new substance is formed as a product. These new substances cannot be reversed to form the original substance's reactants. Example of physical changes are melting of butter on a warm toast, melting of ice, inflating a balloon, etc. Whereas the examples of chemical changes are during the process of rusting, iron reacts in the presence of moisture and air to form rust. We cannot get iron back from the rust. Now let's know about the chemical equation. A chemical equation is the symbolic representation of a chemical reaction. Reactants are written on the left hand side of a chemical equation, while the products are written on the right hand side of the chemical equation. Reactants and products are separated by an arrow in a chemical reaction. Rusting. Rusting is a chemical reaction where iron reacts with air in the presence of moisture and forms a brown powdery substance. This brown powdery substance is called rust. Rust is a chemical substance also known as hydrated iron oxide. Rust is harmful to iron objects and slowly deteriorates them. Rusting can be prevented by galvanization. Now we will know about the characteristics of a chemical reaction. The first is change in color. Change of color of an apple when kept in the open is an example of chemical reaction. Similarly, phenolphthalein is colorless, but when it is added to dilute dilute sodium hydroxide, the solution turns pinks. Change in energy. In some of the chemical changes, energy is either absorbed or released. This energy can be heat energy, light energy, or electric energy. The most common type of changes in energy is found with respect to heat energy. Based on the absorption or release of heat energy, chemical changes can be classified as exothermic and endothermic. The chemical reactions or changes in which heat is released during the reaction are called exothermic changes or exothermic reaction. Example is when carbon is heated in air, heat is released. In endothermic chemical reactions, heat is absorbed. Boiling of an egg and baking biscuits are some examples of endothermic reactions. Other examples are when carbon and sulfur are heated, heat is absorbed and carbon disulfide is produced. Change in state. When electricity is passed through water, it produces hydrogen and oxygen gases. Here, a liquid turns into a gaseous state. And some other characteristics are generation of smell, release of light and sound, formation of precipitate. Now we will know about the different types of chemical reactions. Precipitation reaction. A precipitation reaction is a reaction in which two aqueous solutions are mixed and result in the formation of an insoluble substances or solid. When two solutions are mixed, cations and anions of the reactants combine to form the solid, known as precipitate, and the reaction is thus known as precipitation reaction. Example of precipitation reaction is when silver nitrate is added to sodium chloride, a precipitate of silver chloride is formed. Combination reaction. In a combination reaction, or we can say synthesis reaction, two or more reactants combine to form a new product. Example, Gaseous nitrogen reacts with gaseous hydrogen to form gaseous ammonia. Decomposition reaction. In a decomposition reaction, a single compound breaks down into two or more products due to the breaking of bonds. It happens due to the action of light or heat. Example of decomposition reaction is when solid calcium carbonate decomposes into solid calcium oxide and gaseous carbon dioxide. Single displacement reaction. Single displacement reaction is a reaction in which a more reactive element displaces a less reactive element from its salt solution. Example is zinc displaces hydrogen from hydrochloric acid to form zinc chloride and hydrogen gas. Double displacement reaction. In double displacement reaction, positive ions and negative ions switch their positions and form new products. In these reactions, two elements or compounds are displaced. Example, when sodium chloride reacts with silver nitrate, silver chloride and sodium nitrate is formed. Oxidation reduction reaction. An oxidation reduction reaction involves the transfer of electrons between two reactants. It is also known as a redox reaction. Oxidation reaction involves the loss of electrons, whereas reduction reaction involves the gain of electrons. The substance which gets oxidized is known as a reducing agent, while the substance which gets reduced is known as an oxidizing agent. Oxidizing agent removes hydrogen or provides oxygen to a substance, whereas reducing agent removes oxygen or provides hydrogen to a substance. For example, when ferric oxide reacts with carbon monoxide, ferric oxide is reduced into iron and carbon monoxide is oxidized into carbon dioxide. Separating a solid from a solution. Both evaporation and crystallizations are the processes by which we can separate solids from their respective solution. Evaporation. Evaporation is used to separate a solid from a solvent. Interestingly, the rate of evaporation can be increased by heating. This technique is also used to separate mixtures. In this method, water is boiled in an open container. After some time, the water molecules start losing surface water and enter into air as a gas. As a result, water evaporates and becomes water vapor, and a comparatively lesser amount of liquid with solid solute is left behind. Crystallization. Crystallization is a technique used to obtain a pure form of a solid which has been dissolved in a solvent. On cooling, in this technique, the solution is heated in an open container. When the solvent evaporates, the saturated solution is left behind. When it is cooled down for a few days, the saturated solution starts forming solid crystals. These crystals can be then collected and dried out. Crystals of sugar can be formed after crystallization of sugar water solution. Thank you.